The current criteria by which we evaluate our own abilities and identify areas for improvement are subjective, leading to unreliability. We often rely on gut feelings and qualitative judgments that have great uncertainty and can change over time, such as when we identify our strengths and weaknesses with a personal viewpoint and without a quantitative lens. Therefore, we want to develop a smarter quantitative system that can provide such quantitative feedback to ability assessment and learning, which we believe is possible with tools like item response theory and AI models, which allow students like us to know our own abilities on a more continuous spectrum and identify which sub-concepts within a broad skill level will be helpful for us to catch up on. We will additionally be able to have a consistent source of feedback that allows users to benchmark their progress over time. Here are our aims of the project. We want to visualize relevant concepts together, providing a quick overview of one's abilities. We want to utilize modern advancements in AI and item response theory for tailored student learning. We want to empower educators with tools to create high-quality assessment items and monitor student progress effectively. Lastly, we want to foster collaboration and knowledge flow through easy exchange of user-created tools. For our tech stack, we used Git for version control. We used a front-end, back-end infrastructure for our project. For our front-end, we used React with TypeScript as well as Firebase for authentication. For our backend, we used Go, Python, and Postgres, which was containerized using Docker. For software engineering practices, we first used GitHub as our version control system to manage our code base efficiently. The use of branching also allows us to make changes in parallel without affecting one another's progress. The ease of merging using Git is also highlighted, as files can be compared effectively and only files with merge conflicts need to be handled. We have also configured our codebase to be pull request based, with no direct commits allowed. This ensures that changes to the codebase can be controlled and managed based on order of importance rather than chronologically. The segmentation of work into branches also allows us to conduct code reviews for major features, which allows us to verify and correct for each other's blind spots and ensures that we are kept up to date with each other's work. For project management, we have adopted an agile approach to development with the use of sprints to prototype iterative versions of our application. Our agile approach is augmented with the use of Jira. We are able to define the tasks and assignments for each sprint in an easy-to-use graphical format. The use of Jira allows us to gain an overview of each sprint's progress, which is beneficial in our sprint reviews to discuss and discover areas of improvement in further sprints. We are then able to view any remaining work during sprint planning to define the tasks for the next sprint. The use of GitHub issues allows us to link specific pull requests and highlight bugs or areas for improvement in our code base. We can then consider in sprint planning if such issues should be prioritized. For testing, we are using Vitest and Ghost testing library to run our unit tests for the front end and back end respectively. This shall be expanded with integration or end-to-end testing using tools like Playwright in the future. We have utilized mocking tools like Mock Service Worker to simulate back-end responses. This isolates the component being tested from its dependency to back-end calls, ensuring that the behavior of the component rather than the back-end API is being examined. For code quality, we have ensured that our code adheres to best practices. We have used the separation of concerns and the single responsibility principle, ensuring that our file structure and packages are split cleanly based on their functionality within the code base. This facilitates code velocity as we do not have to worry about knock-on effects within our code. We have also abstracted the use of common components into our commons folder, facilitating code reuse. The reuse of code allows us to change one part of our code base and affect all dependent files cleanly, ensuring that our application feels consistent to the user. We have used Docker to containerize the backend. By programmatically defining the dependencies, setup orders, and commands to run in an isolated environment, we are able to automate the setup and teardown of backend services on demand, increasing development velocity as any changes can be quickly tested. The isolated environment in its container setup also helps to ensure that the setup is functional and reliable for all developers. Using GitHub Actions, we have implemented a continuous integration check in our front end and back end. For every commit, a containerized process is run on the cloud using the committed code and tested from scratch. This ensures that our commits can run reliably in an isolated environment. It also catches build or test errors seamlessly, correcting them as needed. We have also activated the continuous deployment process for our remote deployment choices. Every commit to the main branch triggers rebuilds in both Vercel for the front end and Railway for the back end. Continuous deployment allows us to quickly catch any errors that could arise from production environments, such as cause issues for front-end back-end communication, secrets management, minification with Webpack, etc. Lastly, here is our entity relationship diagram.